One application of solving polynomial equations is conducting a break-even analysis. What we have graphed in this picture is a company's profit function, capital P of X. There are a few things that we can observe about this graph fairly easily. The first is that there's a section of the graph that's above the x-axis where our function values, our y values are positive. And then there's a portion of the graph where our function values are below the x-axis, meaning our function values, our y values are negative. So this region, or the portion of the curve that's above the x-axis, is where our company is making money. If the function value for your profit function is positive, that means your profit is positive, you're earning money. And the portions that are below the x-axis is where your company is losing money. So profit is negative. Costs are outweighing our revenue, the amount of money that we're bringing in. So obviously what we want as a company is to have our profit in the positive, but there are specific points where our function value changes from positive to negative, and it's those points that we're going to be interested in when we talk about break-even analysis. So in order for a function to change from positive to negative, it has to pass through 0 if that function is continuous, which this one is. So in order for our profit to start off negative and change to positive, at some point we have to hit a function value of 0. So at these 2 points, our total profit is 0. Because the same thing will happen on the high end of this curve, profits are continuing to stay positive and then at some point transition back to being negative. But to make that transition, they have to hit 0 first. So at these 2 points, the total profit for this company is equal to 0. And those are referred to as the break-even points. The company isn't making money, it's not losing money, it's bringing in as much money as it's spending. So the company is breaking even. And in order to find those points, what we're going to do is solve our profit function set equal to 0. So determine where our profit function takes on a value of 0. We can look at that in example 4, where we're given the profit function for a particular product, where X is the number of units produced and sold in hundreds. We want to use Symbolab to provide all solutions to that profit function set equal to 0. So we'll switch over to Symbolab and we'll ask it to solve this profit function, negative 0.0086x squared plus 6.4194x minus 1025.5404 set equal to 0. We come up with 2 solutions in exact and decimal form. We want those answers in decimal form. Which will be 231.64063, and on, that decimal keeps going, and 514.80122. We would round those values to whatever decimal place we are asked in a homework question, and then in part B, we're asked to find the break-even points for this product. We basically have those answers, but we need to make one small adjustment. We're told in the problem that X is the number of units produced and sold in hundreds. That means we need to take each of these values times 100 to get the real world practical value that that number represents. So in this case, we would take that decimal place in each number and move it to the right twice, since we're multiplying by 100. And our break-even points would be at a production level of 23,164, which we'd want to go ahead and round to the nearest whole number since we can't produce a fraction of a product, and 51,480 units. So when our company is producing and selling either 23,164 units or 51,480 units, then they are breaking even. They are bringing in as much money as they're spending. We can do the same thing in example 5, but we're given some slightly different information to start off with. Rather than being given the profit function, we're given the cost and revenue function. But profit is always equal to revenue minus cost. So what we can do first is generate that profit function. By typing in our revenue function. And then subtracting our cost function. But we need to be sure to put this cost function in a set of parentheses to ensure that that subtraction step gets distributed across these terms. Or we could take care of that manually as we type it in. But if we subtract that cost function inside a set of parentheses, the output will be our profit function. And then we could type that profit function in again and ask Symbolab to solve that equation set equal to 0. Our solutions in this case should end up being x equals 7.12999 and continuing on, and 17.11677, ... as those decimals keep going. In this problem, we're told that x represents the number of units produced and sold in thousands, meaning we'll need to take each of these results times 1,000, or move this decimal place to the right 3 times. And then keeping in mind that what we're talking about is production level, units produced and sold, we need to round naturally to the nearest whole number. That means our break-even points would be at 7,130 units and 17,117 units.